Good day, everyone. My name is Mary Gracie Habolinga and I am student number 26. In this video, I'm going to discuss about joints in concrete pavement. So first, let us know the objectives of this report. So the first objective is to learn about the importance of joints in concrete pavement. Second is to know the four basic categories of joints and their functions. So joints are purposefully place discontinuities in a rigid pavement surface force. All types of joints are used in the rigid pavement construction methods for all PCC pavement types. So a few decades ago, structural engineers, research engineers, and materials engineers in our highway departments have learned a lot about efficiency of joints in concrete pavement. So let us know the importance of the joints in pavement, in concrete pavement. So the main purpose of joints is to relieve part of stresses developed due to temperature variations in the slab. So the importance of joints in pavement is simply because these joints serve one or more of several possible functions, including control cracking, provision of load transfer, isolation of structures that move or behave differently, and of course the provision of plane or shoulders delineation. So these joints can be divided into four basic categories. So they are expansion joints, contraction joints, hinge joints, and construction joints. So first let us know the meaning of expansion joints. Okay, so an expansion joint is placed at a specific location to allow the pavement to expand without damaging adjacent structure in the pavement itself. These joints are usually transfer joints used to relieve expansion stresses in the concrete by providing room for expansion. So expansion joints are provided in transverse pavement at a long interval. Okay. So the expansion joints are formed as through joints across the full depth of slab, about 200 mm gap between the two slabs. So the expansion joints provided after a number of contraction joints. So the concrete pavement slab is separated across expansion joints. So therefore, there is no load transfer across the expansion joint. So weak cross section of the CC pavement is in expansion joint. So in order to strengthen this section and to provide load transfer across the expansion joint, suitable dowel bars are designed and installed during construction. So in this joint, the expansion filler prevents aggregate interlock from serving as load transfer. So dowels or other load transfer devices must be provided between slabs. These dowels must be free to slip in the concrete to permit horizontal movement in the joint. So let us move the contraction joints. So a contraction joint is a sawed, formed or tooled groove in a concrete slab that creates a weakened vertical plane. It regulates the location of the cracking caused by dimensional changes in the slab. So contraction joints are formed by cutting grooves across the pavement slab at regular intervals. So width of grooves is not less than 3 mm. Depth of groove is 25 to 30% of pavement thickness. Spacing of two contraction joints is 4 to 5 meters. So this space in the middle is what we call the groove. So shrinkage cracks develop along these predetermined sections only or in contraction joints. So in order to prevent widening of these fine shrinkage cracks, steel reinforcement may be provided across the contraction joints. So unregulated cracks can grow and result in an acceptably rough surface as well as water infiltration into the base, sub-base, and subgrades. which can enable other types of pavement distress. So contraction joints are the most common type of joints in concrete pavement. Thus, the generic term joint generally refers to a contraction joint. So closely spaced contraction joints help to relieve part of the warping stresses developed in the pavement. So let us talk about hinge joints. So the term hinge joint applies to any point which permit hinge action but no appreciable separation of the adjacent slabs. Hinge are usually installed in conjunctions with reinforcement pavement and are intended primarily to control warping stresses. So in contrast to contraction or expansion joints, appreciable changes in joint width are prevented by steel reinforcement or bonded steel dowels passing through the joint. In effect, a joint of this type acts simply as a hinge. It merely permits a certain amount of vertical angular displacement of the debuting slabs. So hinge joints generally are constructed in the same manner as groove contraction joints, except that in reinforcement pavement, the longitudinal reinforcement is not interrupted, but is continuous through the joint, thereby allowing hinge action without appreciable slab separation. So the first one is the conventional dowel bar. So this one in the middle is the dowel bars, which holds the two separate slabs together. So the letter B is the hinge dowel system. So in the middle part of letter B is the hinge. So they call it hinge dowel systems. So in the absence of reinforcement, bonded dowels are used to hold the slabs together. So load transfer is usually across by aggregate interlock. So there is a load transfer between the two pavement or between the two slabs because of the bonded dowels between them. So let us move now to contraction joints. So contraction joints are formed due to gaps between continuous works. So a contraction joint is a joint between slabs that result when concrete is placed at different times. So workers manually insert dowel bars into the construction joints at the end of the workday. Contraction joints should be planned so that they coincide with contraction joint spacing to eliminate extra joints. So it is necessary. So in construction joints, it is necessary to provide dowel bars across this joint for load transfer. So there are two types of construction joints. So the longitudinal joints and the transfer joints. So longitudinal constructions are used between concrete lanes paved in separate passes. Okay, tie bars are also help to prevent the joint from opening. Keyways and dowel bars alone do not. Okay, so the functions of the longitudinal joint also the lane markings in highways with two or more lanes. So as you can see in our highways, there are longitudinal there are I mean they there is a longitudinal joint between the two lanes, so it separates two or more lanes. So tie bars can be used in this longitudinal joint. Okay, not unlike keyways or dowel bars alone do not, but tie bars can be used alone with longitudinal joints. So the need of this longitudinal joint is to prevent shrinkage, cracking happening during the initial period of curing of the pavement. So now let us study about transfer joints. So transverse construction joints, also known as header joints, are built at the end of the section of pavement to facilitate continued pavement construction. So typically constructed perpendicularly to the pavement center line and may be constructed using framework or by sewing. Okay, so I'm gonna show you the longitudinal joint and transfer joint. So these are the component of a pavement. So this one, the one who is holding the two separate slab the are the dowel bars. So this one, the longitudinal joint is parallel to the pavement, to the highway to the pavement highway, and the transverse joint is perpendicular to longitudinal joint. So transverse joint can be constructed in can be constructed by slab. I mean by two separated slabs. So this one in the middle, the the tie bars hold the longitudinal joint together, and the dowel bars for four transfer joints. So that ends my report. Thank you for watching, and I hope you learned something. Thank you so much.